So a quick introduction on me. I'm actually both way. I'm a musician at the first place. I study at the Royal Music Conservatory of Brussels. I study music theory and orchestration mainly. I taught for 5 years the music, mainly saxophone and clarinet, and at the same time I study the computer science with specialization in database and architecture. And I'm also part of entrepreneurship because I launched a MusiMap a few years ago when I met Pierre Lebec 10 years ago actually, who is a musicologist, and he has a big dream. Sorry for that. What? Thanks. So we found MusiMap 10 years ago, and at the very beginning of this project it was a B2C company, and we decided to build this huge database about music and to expertise every artist, every songs in the world. Of course that was very difficult as a project, and it grows up to a B2B company now with intelligence and machine learning and deep learning. But at the very beginning, it was the main purpose of this project was no one can create music without any influences. That means if you always listen to classical music, for example, and I ask you to compose some heavy metal music, even in this particular songs that you will compose, we will find some classical influences. So for that, we create a huge map of genres, musical genres, and we have repertoried 400 genres. And all those genres are influences from or to. That means, for example, the rock could not exist without the Afrobeat, for example, and the punk would not exist without the rock. So all those genres are in a relationships, and that's the main concept of MusiMap. Then we are working a lot of moods. The moods are what you are feeling when you are listening to music. And for that, we based our lexicology on the Chinese medicine with the 6 elements: the metal, the air, the ground, the wood, and those. And then we subdivide those 6 families into moods, complex moods. And for example, we can find the mood, the feeling sad with the feeling nostalgic, for example, in the sensibility family. That's all the moods you can have when you listen to music. Then we expertise the artist. And an artist, as I told you before, cannot compose something without any influences, because the artist always listens to other artists. And in this example of Adele listened a lot of Ella Fitzgerald, for example, or she listened to Duffy, and that makes what at the end she composed by herself. And of course, if it's in one way, the other way exists also. So Adele influences other artists, and because of all this relationship between artist and genre, we could compute some similarities between artists. And so we could compute that Adele and Amy Winehouse are similar at 68% in our algorithm, for example. At the end, so we analyze genre, we analyze artists, and of course we analyze songs, and we put a lot of tags around those songs. And those tags are repertoried between keywords or genres or mood or language, the tessitura, the voice families. Actually, every word you could use when you describe music, because when you are telling something about music, you are not only telling, okay, this is rock music or this is sad music. You have a lot more nuances about the word. And we aggregate all those words, and that makes the expertise of MusiMap. At the very beginning of the project, 10 years ago, we worked manually, and we expertise manually 1.6 million of songs. But right now, there is 50 million songs in the world, in the global catalog. I will not talk about SoundCloud or the private songs on YouTube, for example, but on the main catalog through the major, we have 50 million songs, and we own all those songs in our database, and all those songs are expertised in this way. At the end, what MusiMap does, it's an API. We provide our clients with an API, and through this one, they can have data enrichment. So if they just want to put some more words on the profile on their interface, and we provide them also with search engine. And searching a song is not only I want rock music and we provide you with rock music. It's also recommendation, it's also radio, playlist, personalized playlist, and all of that, we provide our clients with this. At the end, we also do profiling, because we cannot do personalized playlist if we don't know you. And by this, we will analyze actually all your listening history when you are connected to Spotify, to Deezer, to Cobuzz, to YouTube. All your history is analyzed, and we can get a profile of yourself and recommend by this the right song for your next listening. And yeah, some of our clients are Cobuzz. Cobuzz is a French streamer, Vivo, Universal, SiriusXM, BMG, and other ones that I can know. So MusiMap at the end is between the artificial intelligence and the human intelligence. In the part of the human intelligence, we worked in the past with something like 60 experts in the musicology, but not only, we work also with neuroscientists, psychologists, lexicologists, philosophy, sociology, and music therapy. And in the part more technical, we work with Neo4j engineers, with machine learning, the signal analysis, of course, but also deep learning, neural networks, and the collaborative filtering. I will explain this later. So, why the music is so important in our life? The music is actually everywhere. When you are listening to a movie, when you are listening to the radio, when you are working, maybe you are listening to music. When you are running, you can listen to music. The birds does music. I mean, the music is really everywhere. And in the 90s, Hervé Platel, which is a neuropsychologist from France, find that the music engage the brain in its entirety. And actually, that's the main discovery, because so far we always thought that the brain is only working on the left side or on the right side. But actually, the music is the only one thing in the world that works with your brain in the totality of it. I mean by that, when you are listening to music, if we are just thinking 2 seconds on it, what happens? The first thing is the memory. And with the memory, your brain will first try to remember, do I know these songs or no? And if you don't know it, you will try to remember it for the next time. And that's, you cannot control this. This is the brain. The second thing is the traction. Actually, when you are listening to music, you can beat the measure with your foot, you can dance, you can just move, actually. But when you are listening to music, you don't control your movement, your traction. We also have the language, of course, because when you are listening to music, you will analyze the lyrics, you will try to remember the lyrics, you will maybe sing the lyrics, so also the language is a part important of your brain. And at the end, we have the feelings, the emotion. So when you are listening to this kind of music, you will feel good or sad or happy, those kind of stuff. And all those 4 ways of work will improve your brain, and your brain will create new synapses, actually. And that's the only way of how your brain works with music. Here, for example, it's just a comparison of your brain when you are listening to rock music on the left and classical music on the right. You see that the brain is working on somehow. Not on the same part because it's not the same music, but the 2 parts of the brain is working. So I told you that we do profiling, and profiling is very important, and not only in music, but everywhere in the internet. For example, we provide it on the internet for the music industry. But what's profiling means? So the profiling is actually the recording of all your activity in internet in this case. So the recording of analysis of person psychological and your behavior. And by that, we did an example 2 years ago, something like this. We took the playlist of Barack Obama, and it was just before the new election. And Barack Obama released on Spotify 2-3 playlists, and we took the night playlist. 20 songs. We match the 20 songs with our database, and we can analyze and say, okay, mainly he has this kind of mood, this kind of genre, and by expertising this thing, we could actually do a psycho-emotional profile of Barack Obama. So we have mood, we have genre, but we have also a lot of words. Just, okay, it seems that Barack Obama liked Afro-American music, blues music. He liked to have candlelight dinner with music, English mainly. He liked jazz. He liked the music which is romantic, sensual, made by a singer-songwriter, and those kind of stuff. That's the analysis of the real Barack Obama playlist. So at the end, this is not very interesting, except for us, because we will use this to create new recommendation. But if we want to be more complex on it, we can do some psychology on it. And at the end, we can say that Barack Obama, based on this specific playlist, favors sensuality and charm, for example, or can appreciate snug, peaceful moments, and can also be very proud and charming. And actually, I don't think that somebody in this room knows really of Barack Obama, but by what we saw from him, actually that fits quite very well. I mean, I just will do a little remark on this. So we took this example, and this example is really nice, but of course, when you know that, you can also play with it. And by playing, I would say cheating, actually. Because I don't really think myself that the playlist he released was the real one. I mean, the communication for the White House could and we really think they did change something and select the right songs to put a profile that corresponds to a president, actually. So when we know all of that, we can recommend some music to Barack Obama, and we could say, oh, Barack, you seems to like jazz, so why don't you listen to Miles Davis and Blue and Green, because these particular songs of Miles Davis could really fit your taste, and you could really like it. And all those songs, we can recommend it. And what we do that, when we do that with Barack Obama, actually we do that for a lot of people in the world through the streamers. They are using our API. So having all those information, it's not 2-3 information per people, of course, because we are tracking all your activity when you skip a song, when you listen several times the same songs, what's your playlist, and all those kind of stuff. We also have to store in our database all the expertise we are using, and that's big data. But what's really big data? Big data, actually, it's quite a new term, 10 years ago, something like this, that describes all the data you can have and you can manage, but not in a reasonable time frame. So if you have too many data and it takes too long to treat those data, to find your way in those data, that's big data. And usually we are talking about the 5 V's of big data. The first V is the volume. Of course, we don't do big data with 2 information. We also do velocity. The velocity is the speed when the data is generated. I mean, if your catalog only increase every years, it's not really big data. For that, you need to have new information quite every minute, and that's the activity of the users on the stream. We also have the variety, so if you only focus on one topic, it's not real big data. It's small data, but not big data. In our case, we are working on artists, on tracks, on users, on brands, and all those kind of stuff makes the variety of the data we are using. Then you have the veracity of the data. You have to trust your data, and if you don't, you will not be able to use them. For example, we analyze manually 1.6 million of songs, and those songs are the ground truth, the knowledge of the machine learning. If we made mistakes at this time, actually the machine learning will not work well, and we will expertise some wrong things about you. So the veracity is very important. And then, of course, the value, because we don't just keep data for nothing. We have to use those data, and that's the value. If you don't do anything with those data, it's just, okay, storing statistics, storing information, but you have to do something with it. This is the 5 V's of the big data. Some statistic about our lexicology or catalog. I will not speak here about the user's profile, but we owns 50 million of songs with pre-analyzed moods. We have 4.5 million of artists and an average of 12,000 words, keywords, genre, mood, listening context. And because we are building a huge relationship, a huge network, we have 3 billion of relationships. Just for you know, quite every year we have more than 1 million of songs. In 2016 we had those 1.3 million of new songs, and those new songs have to be expertised and stored in the servers we have. So when I explain you that we expertise music, how we do that, because we will not expertise 50 million of songs manually, we will not expertise more than 1 million of songs every year, that's not possible. So the first thing is the social filtering, and the social filtering is an aggregation of all what the world says about the music. So we scrap some partners, such like Spotify, such Wikipedia, AllMusic, and those kind of sources, and we take all what they say about a specific artist or track. But the problem when you do that is if Wikipedia, for example, say, oh, this song is indie rock, and if Spotify say, yeah, this song is also indie rock, maybe it will not be the same indie rock at the end. So we have experts in MusiMap, and those experts analyze every concept of the word, every lexicology of our partners, and they do filters, and they say, oh, okay, actually when Wikipedia says it's indie rock, actually it's not really true, it's alternative rock in this case, and when Spotify say the same thing, actually we can believe this is really indie rock. And all those filters are the social filtering we are using for the music. This is the first step of the analysis. The second step is the audio analysis, because of course the music is something that you are listening to. So we have all those audio files for the 50 million songs, and we expertise them, we analyze them through several layers. And we retrieve some information. The basic one are the BPM, the sound key, the tessitura, and those kind of stuff. But we also are taking a lot of other features that we will use in the deep learning process that we will explain later. So the deep learning is something very interesting now. It exists since more than 13 years actually, but right now we are talking a lot about machine learning and deep learning and artificial intelligence. And that's the process that will help our experts to analyze every songs, because yeah, we will not do it manually. And by deep learning we will increase our expertise, and we will be able to expertise the 30,000 new songs per week. And we also can analyze all your activity on the streamers and all the playlists and all those kind of stuff. So we have social, we have the audio, we have the machine, but we miss something, and we miss the validation. And the validation is done by the experts. So we have a team of experts in MusiMap, and they have a very cool job because every day they're just listening to music. And when they are listening to music, they have tags, actually, and they just validate the tags and say, oh, yeah, this is actually real rock, or this is wrong, I need to change this. They also correct a lot of mistakes in the world, because in the music industry, we have quite problems with artists. They are quite funny sometimes, and the artists could name themselves John Smith, but we don't have only one John Smith. If I take an example more known, Michael Jackson. If I ask you who is Michael Jackson, you will all of you tell me this is the king of the pop. Yeah, maybe. Maybe it's also the saxophonist. Maybe it's also the pianist. And actually, there is in our database 4 Michael Jackson, and all are the same names. And when you are treating big data and deep learning, the problem is that you can mismatch those information and at the end corrupt all your expertise. That's why we need human to validate and to correct those mistakes to improve the knowledge of the database. For example, I took here Feeling Good from Nina Simone, very good songs. And I try to just take note of every information we have on these songs. These songs, we have 6 genres. It's not only jazz, it's a little bit of gospel, little bit of blues, also jazz mainly. It's also 2 subgenres, more than 100 moods, and all the numbers you have here. At the end, the full analysis of one song is 2,000 of descriptors. Let's count 2,000 of descriptors for one song. We have 50 million of songs. That means 100 billions of descriptors in the database. And we have to manage this, and this is big data. And this is just the expertise. I don't tell you about how many people in the world have these songs in the playlist, and how many people listen to these songs, how many people favorite these songs, because that's not the same things. And that's all other information we have on the songs, and that makes the big data. So let's talk a little bit about technique. I will not enter too much into details, but we are using, for managing all those data, we are using several systems. So you may know Debian, you may know Ubuntu, because that's a main operating system that quite everybody could use, even at home. You may not know Apache Spark, which a pre-processing concept to pre-process all the data when you do machine learning, deep learning of search engine. We may not know about Hadoop and MapReduce, because, of course, I told you that we have 100 billions of descriptors that doesn't fit in one database. So we need to separate in several databases, and for that this is Hadoop, and we need a summary, a way to know in which database the information exists, and this is MapReduce. And just because we don't want to install the same machine several times, we use also Docker. Docker is just a mirror of a server, and by this you can duplicate really quickly all your stuff. Then we have database, of course. The database we are using is Neo4j. This is our main database. Neo4j is a graph database, so the graph database is really consistent to our project, because since the beginning of my talk, I explained you that we are working in a relationship network, and the Neo4j is really fits to that. It's not a relational database, it's a NoSQL database and graph database. So Neo4j is really good when you have to traverse information and to go from point A to point B. But for searching for some words, that's really complicated, and that doesn't really work. So we are using Elasticsearch for that, which is an indexed database. That means that it is really fast to find words when you are looking for something. And because we are not always tacking our database, we need some cache, and we use Redis for the cache. Then, of course, we need some language to write our code, and the main one will be PHP, actually, even if it's an old language. But the main process are written also in Java, and we are using a lot of Python for the data mining we do, for the deep learning and machine learning we do. And regarding this machine learning and deep learning, we are using only Ubuntu with Python, and scikit-learn, which is a framework for the machine learning. And for the deep learning, we are using Keras on TensorFlow, and those are technologies used by Google to analyze all their stuff. We are using the same. And because CPU are not really fitting the huge resource we need, we use NVIDIA GPU. If you are a gamer, you could use actually exactly the same graphical card we are using, just not in the same way. But that's the best actually right now on the market to manage the deep learning. So, something about artificial intelligence. But the first question I will ask is, what's artificial intelligence? Because right now it's just a trend, and everybody is talking about, yeah, we do artificial intelligence, but that's not really true actually. I will explain this later. So the artificial intelligence is the system that perceives its environment, that understands what it happens, and it will take by himself some action to maximize the chance of success. In other words, it's the sciences of making intelligent machine. In this artificial intelligence, you have several fields. The first one is the NLP, natural language processing, is the process who try to understand your request and translate it for the computer. If you are using Alexa from Amazon or Google HomeBot or Siri from Apple, this is NLP. Just understand what you say, what you write, and trying to compute it to the servers. Then you have the machine learning and the deep learning, which is used mainly for deduction, reasoning, for planning, scheduling, and solving problems. That's the main things of the AI. The AI is not really something new, actually. The AI starts in the 50s with the first big servers at this time. Then, but it didn't really work at this time. On the 80s, the neural networks came on the market, and we thought at this time that, okay, this is really nice and the neural network will help us, but it doesn't work anymore. And right now we have artificial intelligence quite everywhere, and we really think, and the experts worldwide really think that now it's really, and it will work now actually. And why it will work now? It's because three things. The first thing is we needed those deep learning process technique and the neural networks. And the neural networks are the main things that allows the computer to really think smart and fast. But to be fast, you need some resources, and 20 years ago, we didn't have those resources. I talk about that, for example, with the cloud computing. 10 years ago, it was just the beginning of it, and it was not useful for the AI. And of course, you need also all the data, and you need a lot of data. And 20 years ago, nobody was really creating data on the internet, except some companies, but it was not enough for artificial intelligence. Right now, you are creating data every day. When you are opening a Facebook page, when you are listening to music on a streamer, when you are watching videos, you are creating data, and those data are used to improve the AI. A little bit about Yann Lequin, which is the father of the neural networks. It's a French neuroscientist. Actually, he has a very right vision of the AI. And regarding him, right now, even if if I go on the street and I ask to a random person, what do you think about AI? And he will tell me, yeah, AI is now, and AI is working now. Actually, no. And Yann Lequin told us that only 5% of the AI is working now. And so there is a huge steps to do in the very next few years to achieve a real AI. And why I told you about real AI and why I explain you that AI actually right now it's not really intelligent, that's concept. It's just because the AI right now is really, really, really good to do one thing. Not two, only one. So you will train your deep learning process, you will train your intelligence to do something, but if we want to copy the human brain, it will not be the same because you can do several things at the same time, and that's a real intelligence. So in this case, we are talking about AGI and not really AI. That's the big differences. The first part of the AI is the machine learning. So the machine learning will give to the computer the ability of learn by himself. For example, we have this car, and we want to know if a picture is a car or not. In the machine learning, we have an input, a picture, and we need to extract features of it. So human, that's the problem of the machine learning, the human will need to describe what's a car. A car is something who has two wheels, who has a window, who has doors, and those kind of stuff. The computer will extract all those information, and when he will see other picture, he will say, oh, okay, this picture are two wheels, have window, have the door, okay, this is a car, no problem. And for that, of course, you don't need only one picture, and there is a lot more descriptors than those I told you. So we need a lot of picture of cars. And the funny thing is, actually, a car is not only a working car. You can put in the machine learning crashed car after an accident. You can put buses. You can put a motorcycle. And at the end, regarding all those descriptors that the human put in the machine, the computer will be able to say, okay, this is a car, this is a train, this is a bus, this is all those kind of stuff. For the music, of course, we don't talk about wheels, windows, and doors. We are talking about spectrogram, rhythm pattern, spectral descriptors, and all those kind of stuff. And that's what we do. So for the musical expertise we are doing, the feature we are using are the analyzing of the segments of the songs, and we get all the pattern, histogram, and descriptors. We also have the BPM, key detection, danceability, the energy of the songs. That's all the descriptors we are using to feed the machine learning. For example, on the left you have the classical histogram, and on the right you have the rock histogram, and you can see the differences between the two histograms. That's what the machine could see if it has eyes. So that was the machine learning, and every year in the world we have a contest about the large-scale visual recognition, which is a challenge to recognize pictures through machine learning. And in 2010, 2011, as you can see, we made progress. So the percentage you can see is the percentage of errors. So the less we have errors, the best it is. And suddenly, in 2012, we have one stranger that came in the game, and that won actually for the first time in the history this challenge. And there was the supervision of Yann Lequin that I told you before, and there was a deep learning process. And before that, because Yann Lequin was working on deep learning since the 80s, everybody was talking, yeah, okay, deep learning, that's really nice, but we will not do something cool with that. And in 2012, actually, he proved the opposite. And the funny thing is actually that in 2013, everybody was doing deep learning instead of machine learning. And that's how we improved a lot the artificial intelligence in the world. But what's the real difference between machine learning and deep learning? So the machine learning, I told you that the human have to extract feature to explain to the machine what he has to know about what he has to recognize. Here, with the deep learning, we create neural networks, and the neural networks actually are the way of the machine to understand by himself what's a car, what's a bus, what's a house, what's a tree, and those kind of stuff. So the human doesn't go in this process, and I think that's a good thing. So we have always this input, we have always this feature extraction, but now we have the classification for the deep learning, and at the end, okay, the machine will not really know that's a car, he will not really know that's a bus, he will just say, oh, this is the same picture on this one, the same group. And because at the end, in the server, we know that this group is the bus, we know that this new picture is also the bus. That's the classification. But how it works? So the neural networks consist of layers. So we have the input. The input is two wheels, two windows, the doors, and those kind of stuff. And we have the output layer. The output layer is, this is a car, this is a motorcycle, for example. The neural network is all those features, they are linked one to the another in the middle, and the process of computing this output layer. And why is it deep with a neural network? Is because we don't have only one middle layer, we have a lot of middle layers actually. And when I told you that we have 1,600 audio feature for the music, that means that we have 1,600 middle layers. And every of them are linked to the another one. And that's the deepness of the neural networks for the deep learning. The problem with that is that it doesn't really help us at the end to manage those things, because we need a lot of resources. Mathematically, it's really complicated to imagine and to solve the problem. So we need some help from the machine. And when the machine learning is using CPU, the deep learning is using GPU. And the GPU is between 20 and 50 times faster than the CPU. And right now, and that's why we really and strongly believe that the AI will work right now, Google announced that they will release the TPU, which should be 10 times more faster than the GPU for next year. So how it works at the end, if we take the image recognition, we will create a convolutional neural network. That means, let's say that you have a picture of 40 million of pixels. That's the new camera of Nikon that they will launch this year. So we have 40 million of pixels, and the computer will analyze every single pixel of this picture. And it will try to understand what makes something. And you will see, okay, this groups of pixels is an eye. Oh, I have a second eye just beside. Oh, I have a nose. That should be a face, actually. And that's how it works. So, for example, I'm sure that you know that Apple released a new iPhone with the Face ID. Actually, this is the Face ID of Apple. So the smartphone, the Apple 10, will analyze you through those camera, and will analyze you on several points. And regarding those several points, it will allow us to recognize you, and in this case, to unlock your phone. And that's why it will work even if you have a hat, a beer, or something like this, is because you have so many points in your face that it will work. No problem for that. But we talk about face, but of course it's exactly the same thing for the all other things we could recognize in the internet. Is the face, the cars, the elephants, or the chair. So the first pixels are always analyzed, And because the nose is not the same from an elephant to a human, and all those details, at the end, it will distinguish those information. For the music industry, how we are using deep learning and machine learning, this is in several ways. We are using them for classification, so to help the experts to manage all those songs and to correct error. So we predict some genre. The prediction is not something obscure that it just a medium could say. The prediction in the AI is just the process of the output layer that we explained in the deep learning process. So we have genre. We know that we can provide and feed the machine or the deep learning with a lot of thousands of music from the same genre. At the end, we can say that, okay, these new songs by this expertise is predict as the same genre. That's the same for moods also. And then we have the classification. The classification is more used for us for distinguish between female and male artists, or if the track is instrumental, live, a cappella, and those kind of stuff. And then we can use machine learning and artificial intelligence for the search prediction. So when you type something on the autocomplete field, for example, we could, through the machine learning and through the NLP in this case, predict what your next character will be. If you are typing Christmas, for example, we could deduct, and you could do it actually, that after the M it will be a just because we understand that you are typing Christmas at this time. We also are using it for the songs recommendation. So we do audio similarities just to know by expertise how similar a songs is. I showed you at the very beginning not the songs recommendation, but the artist recommendation. Adele was 68% similar to Amy Winehouse. We do the same thing with the songs, actually. Also based on the listening history. If you always listen to French rock or to UK rock band, those kind of stuff, we may understand that you will not be very interested by Japanese rock, even if it's too rock. It's not something that it will really fit to you. So that's the usage for the listening history, and also for the geolocalization. For the geolocalization, if you are Belgium, if you are American, if you are Japanese, you will not understand the music industry in the same way. And that will help us to understand you and to profile you, and actually at the end to recommend you the new music you may like. And that's all, and I thank you for your attention for this talk. And if you have any question, don't hesitate to contact me later, and I will be happy to answer you. Thanks.